So there's another solving lesson starting on the board in which we just directly computed and then we got another answer. That's a bit different. It's because of the G and the F. There's something they used to use the A and B. They used the G and the F and then they computed it directly into the generalized equation. In which in the generalized equation that we inverted the G and F to be the opposite values of G of A and B. And when you invert it, this is the answer you get. But moving on, there's another question I wanted us to solve in which we are finding the length of the tangent of the circle. So finding the length of the tangent of the circle, how do we do that? So how do we find the length of the tangent of the circle? It's not hard. So we find the length of the tangent of the circle. Okay, I'll show you how to do that. Now this is a circle. This is a circle. So this is the center. This is where T starts from. And so this is the center. So we are finding this. Okay. Now this has a value. Let's call this P. Or let's call this T. And then let's call this P. So this is the tangent. Okay. Tangent means it's at 90 degrees to the radius. Okay. So we are finding it, and that one is 8 and 10. This is 8, 10, and then 10 of the tangent. Okay, and then there's an equation x squared plus y squared. So we have the equation x squared plus y squared. Okay, we're just taking typical questions. Okay, x squared plus y squared minus 2x minus 4y minus 2x minus 4y plus 4 is equal to 0. Is that okay? So from the point 8 and 10, so find the length of the tangents. So we have to find the length of the tangent. Now, from this, the first thing we do is that we have to get the value of A and B. Okay? That's why we have to get the value of A and B from the equation. Is that okay? Very important. So quickly, we have x squared minus 2x plus y squared minus 4y equal to 4 equal to minus 4. Remember, taking this over plus minus 4. So we have x squared. Half of this is 1. So that's minus 2x plus 1 plus y squared minus, this is 2. So that's squared is plus 4. So we have minus 4 plus 1 plus 4. Okay. So this 4 cancels each other. So it gives us 1. So what this means is that x minus 1 squared plus y minus 2 squared is equal to 1. What this means is that arrow is equal to 1. Okay? Because arrow squared is equal to 1. Then A is equal to 1 and B is equal to 2. So the point here is 1 and 2. Is that okay? So we have the value as 1 and 2. So we can put it in brackets here that it is 1 and 2. So writing A and B, we have 1 and 2. Okay? Is there something else? So the length of the tangent is what we are looking for. If r is equal to 1, what is the length of this? But before then, let's find this. We can also get this length because this is also like a circle. It is a circle. It's a circle also. And so using the same rule that we used in which to get our arrow, normal, which is arrow squared, which is x minus a squared plus y minus b squared. So instead of arrow now, we're going to get this small t. So let's say this is, that would be t squared. So applying that same basic principle, we have x minus a. This is x, which is 8. y, which is 10, minus 2 squared. Is that okay? Are we following? Are we following? Okay. So t squared is equal to, this is 7 squared plus 8 squared. So t squared is 49 plus 64. Okay. 49, 64, all of that give us, I always like to show up working 10, 11, right? That's what it means. 8 minus 1 is 7 squared. 49 plus 64 is what? Is 113. So t is the square root of 113. So if I have t as 113, what is the value of this one? Okay. Now we use our Pythagoras rule, which is what we have always used, which is what we use now. So we have the square root of 113. So we have this one now, which we'll call the big T, is actually this one minus this, right? That's 113 squared minus 1 squared. So T is actually 113. Now remove it. Minus 1. So T squared is equal to 112. Remember I was 1. You understand? Notice how we got 1. Okay? We took 4 over and then positive 4, negative 4. Open this bracket, you see you get this. Remember it's perfect square. So T, so the length of it is square root 112. So this is the answer for this question, for the length of the circle. Is that okay? That's easy. The next we'll talk about is, so that's how we find the length of the tangent of the circle. Quickly look at the parabola. The parabola. The parabola. Okay. Parabola. So the general formula for the parabola. So the general formula is y squared is equal to 4ax. Y squared is equal to 4ax. You know there's a parabola. It has this shape. So most times, let's just locate the point here. That most times, then put a line of the parabola. Okay, the line of the parabola most times stretches like this. Okay. Okay. Or we can use dotted lines. You know these values have x and y values. Okay. And then this is like a circle, but it's not a real circle now. It has an eccentricity which is turning away from the circle. So most times, how do we deal with this? We say what's happening to the right hand side is equal to what's happening to the left hand side, and then we have some equations which now leads to this final answer. Okay, I really don't have the time to break that down. I really don't have the time to break that down. So just know this is the final formula we arrive at the end of the day. After the right hand side goes to the left hand side. One is on a straight line, so we have our normal Pythagoras rule on one side, which we are subtracting. Remember that once you have this line, just know a triangle has been formed. So we get this value for that line, and then we deal for the other side. Because this is the shape we're dealing with, not this bottom one. But because of this line, now gives us a formula that we use. Then this is the formula for the other side. Sorry, don't want to burden you with too much solving. Too much solving. Okay, let's look at an example. Now, what this means is that if there's a special point here, you now have y1 is equal to 4ax plus x1. That's if we are trying to now get another point on the line, okay, on the line, as the line keeps extending. Remember that's y squared. So this is for to apply to different questions. You use that formula. Okay. No, y times y is y squared. Okay. So x plus x is still x. Okay. So there's no multiplication here. It's addition. So it remains x. 1 plus 1 is 2. Okay. So let's take an example. Let me read up an example quickly. It says find the equation of the parabola whose vertex is the origin and whose focus is the point f50. Find the equation of the parabola. Take note, there's a vertex which is the top, that's the A. A is the value for the vertex. And the A we got just now was when, the focus was at 0. It was at 0. Okay? This vertex is the origin. Whose vertex is the origin. What does it mean by that? That means 0, 0. Right? And whose focus is the point 50. And 0. Is that okay? So the solution. What this means is that we know that our F is our focus and then it's A and 0. That's what it means. Therefore, A is equal to 5 here in this. Therefore, our formula y squared is equal to 4ax. Putting that value, we have y squared equals to 4 times 5 times x. That's y squared is equal to 20x. This is the equation of the parabola. As simple as that. Why is this really done? That's a very direct question. Now we have another question here. Find the equation of the tangent to the parabola. Find the equation of the tangent to the parabola. Okay. Find the equation of the tangent to the parabola. I know we have introduced something like it, but I've already shown you how we get tangent already. The tangent to the parabola. Okay. Tangent to the parabola. Y squared equals to 12x. Okay. At the point 3, 6. At the point 3, 6. Okay. Solution. So first thing is that y squared is equals to 4ax. Now parabola idea. Okay. Tangent idea is equals to 0. So differentiating it, we have 2y dy over dx minus 4a is now equals to 0. Okay. So we now have taken it this way. We have dy over dx is equals to 4a. Okay. 2y. Yeah, so it's 4a over 2y. Same thing as saying dy over dx is equals to a 2a over y. Somebody lost? No. And like Mabu said, dy over dx is y2 minus y1 over x2 minus x1, which is equals to 2a over y. So this is the rule. So we can put that here. That's the equation. Or we can say y minus y1, then x minus x1 equals to 2a over y. Is that not so? Is that quite easily done? Is there an issue? Is there a confusion? I don't think there is. So I just wrote it there so that we can write this. Okay. So this is just the easy way. I'm just showing you the easy way to generate those idea of tangents. You know, what I'm doing is I'm breaking mathematics for everyone. I'm breaking it down for everybody to make it easy. Yeah, that's what I'm doing. Alright. So quickly, I want to just resolve this equation of tangent parabola. So naturally, what this means is that a is equal to 4a is equal to 12. Therefore, a is equal to 3. So the value is what? A of a is 3. Take my value of a is 3. Now the new point, which is what? 3 and 6. Okay, so putting that in the equation, remember 3 and 6 is x and y. It's x1 and y1. 3 and 6 is for x1 and y1. So we have y minus 6 over x minus 3. Also 2a 3 over y. Now which y is this? Now take note, this is also what? Y1, which is what? 6. So we have y minus 6 over x minus 3 equals to 1 over 1. Because y1 is what? 6. Okay. So we have y minus 6 equals to x minus 3. So putting that, we have y minus x minus 6 minus 3 plus 3 is what? Minus 3 equal to 0. Is that okay? So that's final answer. That's final answer. That's okay. That's final answer. Alright, so we're correct. Exactly, we're correct. We are correct. Thank you very much. It's just to apply it. You just need to know how to apply it. Thank you.